What we're going to talk about here is solving by rational equations. And by rational equations, I mean equations that involve rational expressions. All the things that we've been handling before that somehow we've simplified, multiplied, divided. Now we have equations that are involving those, and we want to find all the values of x or whatever variable that we're using to make it true. So we're going to primarily use this lowest common denominator to remove the ratios, and then hopefully end up with equations that look pretty familiar to you. So we're also going to rely occasionally on the zero product principle to solve if we need to. So the zero product principle, if you recall, is when you have two things multiplied by each other, a times b equals 0, then either a or b has to be 0. Okay, so let's say we have something involving constant denominators. We look for the lowest common denominator as though we were going to make these fractions with a common denominator. We use this, but we don't actually retain the fractions. What we do is we'll multiply both sides by the lowest common denominator. And what happens here is that since the lowest common denominator is going to have all the common factors of every fraction that you have in there, we're going to be able to cancel out every single one of those denominators and perhaps have a factor or two left over. So, for example, we have 12 divided by 6. Well, that's going to be 2, so we have a 2 here in front of the x minus 3. 12 times 7 is 84. 12 times x over 12 is just x, and so we have 84 minus x. And so that turns out to be a relatively simple problem. X equals 30. All right. So let's put some variables in the denominator and see now what we get. Okay, so here's one. The first thing that we do is we look for what would be the common denominator, the lowest common denominator, if we wanted to do it that way. So it's going to be 3x, right? We have two factors, 3 and x, and so we'll multiply both sides of the equation by 3x, and then multiply through and canceling the terms. You should never end up with a ratio when you do this at the end, because everything in the lowest common denominator shares factors with all the denominators, so they will always cancel, and you'll just have a factor or two left over in the numerator. So 3x times 8 divided by 3, that the 3's cancel and you get 8x on this side, and 3x times 7 over x is going to be 21, and then 3x over 3x is 1, and so now we have a fairly straightforward, wow, it's writing on mine but not on this. Hang on. Sorry about this. It generally doesn't do this. Okay, so we get 8x equals 20, and so x equals 28 or 5/2. So why don't you try it here? Okay, so what's the common denominator that we were looking for here?
2 times y plus 5.
Great. 2 times y plus 5. And don't feel like you have to expand it, because what's going to happen is like this, where you have 2 times y plus 5, you will have these terms that cancel. So it's perfectly permissible to say 2y plus 10, but it doesn't help you at all because you'll have to factor out the 2 to cancel with the y plus 5. So leave your factors this way. And so your y plus 5 cancels out. You have 2 times 12 is 24. And then 1/2 times 2 times y plus 5 is just y plus 5. And then this one, you just expand that. And so we get then off of that, y plus 29 equals 4y plus 20. And then we collect terms. Subtract y from both sides, subtract 20 from both sides, and you get y equals 3. Okay, everybody okay with this? So let's look at a particular case here, and I want to highlight something that we have to be kind of careful with. So here, the lowest common denominator would be the only factor that we have in the denominator, which is x minus 2. And so we'll multiply both sides by x minus 2. And notice how I use parentheses to avoid missing just writing out the 7. You think, okay, the 7's not a rational expression. You still need to take into account the fact that you've multiplied both sides by x minus 2. So you want to keep that there. And then, so use parentheses to help you along. The x minus 2's cancel. We have 5x. And here the x minus 2 cancels this one, so we have 10, but here we have 7 times x minus 2. And so when we expand that and collect the terms, we get what looks like x equals 2. But we have a problem here. And you need to check this, is we have domain restrictions for these expressions. So they're not really functions, with functions as a domain, but anyway, we look at what values will cause us some trouble here. And if x equals 2, we have division by 0. So all bets are off there, because you can't have, no matter how it works out, you can't have division by 0. And the only solution that we came up with was one that involves division by 0. And it does it in 2 places. So since we found a solution that causes division by 0, we have to exclude it from being a solution. So every time you get a solution, and I didn't do it previously, but you should be doing it from now on, is to check to make sure that you really truly have a solution and not just the result of some mechanical algebra that you did that leads you to something that really isn't a solution. Okay, so let's look at another example here. We have the LCD is x plus 1. And so we're going to multiply both sides by x plus 1. Cancel out the x plus 1s. And notice what happens here. We got a quadratic equation now. Before we had expressions that only involve linear terms. Now we get a quadratic one. And that's okay. We just have to solve it in the way that we normally solve quadratic equations. So the mistake that you don't want to make here is just don't divide through by x, divide both sides by x, and you end up with 0 equals 4x plus 11. What happens is you've lost one of the solutions when you do that. So what you have to do is use the zero product principle here, factor out the x, and recognize that x equals 0 is a solution. Now, x equals 0 is a perfectly good solution. If we put a 0 in here, we get 0 plus 1 is 1. So we don't have division by 0 here. So that solution is good. The other solution is when 4x plus 11 equals 0. And so we can solve for that. We say, 4x equals negative 11 divided by both sides by 4, and we get x equals negative 11 over 4. So now clearly here the negative 11 fourths plus 1 won't lead to division by 0, so we're going to be good there. Okay, everybody good with this? Okay, so I want you to